On the 1st of September 1859, a 33-year-old astronomer named Richard Carrington was doing the most boring job in science. He was drawing sunspots. Every clear morning, he'd project the sun through his telescope onto a card and sketch the dark blotches, one day after another, over and over. At 11:18 that morning, in the middle of his sketch, two beads of blinding white light ignited on the sun's face. He knew instantly that nobody had ever recorded anything like it. He ran to find a witness, and in the 60 seconds he was gone, the lights had already begun to fade. 5 minutes after they appeared, they were gone completely. Carrington had just become the first human being to watch a solar flare. And what he couldn't know, standing there with his half-finished drawing, was that the sun had just fired the opening shot of the biggest solar storm in recorded history. It was already on its way here. In 1859, that meant the strangest, most beautiful night the planet ever had. If the same storm arrived tonight, and it can, it would be the most expensive disaster in human history. Both halves of that sentence are this story. Stay for the second one. That flash came with something else, a coronal mass ejection. A piece of the sun's atmosphere, billions of tons of charged particles, thrown off the star like a whip crack and aimed more or less at us. These things normally take 3 or 4 days to cross the distance. This one arrived in about 17.5 hours because an earlier eruption had already swept the road clear. Nothing that fast had ever hit Earth's magnetic field. 17 hours after a quiet English morning, the whole planet found out what that means. It started with the sky, not a shimmer of northern lights at the pole, but the entire sky, burning red and green and purple over places that have no business seeing an aurora. Cuba saw it. Jamaica saw it. It reached Hawaii and Colombia, practically the equator. In the Rocky Mountains, the light got so bright that a mining camp woke up and started cooking breakfast at 1 a.m, convinced dawn had come early. People in New England read their newspapers outdoors at midnight by the glow. Others assumed their city was on fire, or that something biblical had begun, and honestly, standing under a blood-red sky in 1859, both were reasonable guesses. For most of the planet, that would have been the whole story. A terrifying, beautiful light show, except humanity had just done something new. For the first time in history, we'd wrapped the Earth in wire. The telegraph was barely 15 years old, the Victorian internet, the first machine that made distance disappear. And that night, the wires turned on their operators. Here's the mechanism in one breath. A geomagnetic storm shakes the Earth's magnetic field, and a moving magnetic field generates current in any long conductor sitting inside it. It's the same trick as a generator, except the generator was the sky and the conductor was every telegraph line on Earth. Currents from nowhere began surging through the network. In offices across Europe and America, operators were thrown back by electric shocks off their own equipment. Sparks jumped from the machines and set the telegraph paper on fire. Pylons crackled, whole networks went dead or spat gibberish. And in the middle of the chaos came the strangest conversation in the history of electricity. The operators in Boston and Portland, Maine, both watched their equipment keep running after they disconnected the batteries. No power source at all. The line between them was running on the storm itself, and they knew it. The Boston operator tapped out that he'd cut his battery and was working on, quote, celestial power, and the two of them held a conversation for about 2 hours on electricity that was falling out of the sky. They found it almost delightful. Nobody in 1859 depended on wires to eat. Which brings us to the honest question this story exists to ask. What happens when it comes back? And everything depends on wires. Because it does come back. This isn't a freak event, it's a recurring one. The sun runs on an 11-year temper cycle, and Carrington-class eruptions happen. The only reason 1859 stayed a curiosity is that the only electrical thing we owned was the telegraph. Today, the conductor wrapped around the planet isn't one network. It's everything. Power grids, pipelines, undersea cables, satellites, the GPS timing signals that banks and cell towers quietly depend on. We've already had the warning shots. In March of 1989, a storm far smaller than Carrington's hit Quebec. The grid didn't degrade gracefully. Protective systems tripped in sequence, and the entire province went dark in about 90 seconds. 6 million people, 9 hours, from a medium punch. And in July of 2012, spacecraft watched a genuinely Carrington-class eruption tear through the exact point in space where Earth had been about 9 days earlier. That one missed us by a week and a half of orbit. It carried enough energy that engineers spent the next decade studying it like a near-miss accident report. So the honest math, clearly labeled as estimates, goes like this. Insurance analysts at Lloyd's put a Carrington repeat over the United States somewhere between $0.6 and $2.6 trillion in damage. The scary part of that number isn't the money, it's the time. The giant transformers that anchor power grids aren't sitting in a warehouse. Many are custom-built overseas, and replacing them takes months to years. A bad enough storm doesn't mean the lights blink, it means your phone dies at 3% and there's nothing to charge it with. No card readers, no cold food chain, no pumped water in tall buildings for weeks in the unlucky regions. The miners in 1859 got a free light show because they owned nothing electric. We built our entire civilization out of the one thing this storm attacks. One published estimate from the physicist Pete Riley in 2012 put the odds of a Carrington-class event at roughly 12% per decade. Other scientists argue it's lower. Nobody argues it's zero. And tree rings from the year 774 record a solar event that appears to have been far bigger than Carrington's, so the ceiling is higher than the worst we've ever measured. Before you bunker down, the ending is genuinely hopeful. Unlike almost every disaster in this series, this one comes with a warning. Satellites watch the sun constantly, and a CME takes hours to days to arrive, which is enough time for grid operators to reroute power, unplug the crown jewels, and ride it out. Quebec taught the industry. The 2012 near miss scared the funding loose, and the fixes are boring and real. There's now a spacecraft parked a million miles upstream of Earth, tasting the solar wind and radioing ahead. So when the next big one leaves the sun, we won't be sketching it by hand. We'll watch it coming the whole way in. The sun will absolutely fire at us again. The question is just whether we treat Carrington's 5 minutes as trivia or as the rehearsal notice it was. One last image, because it's my favorite in this whole story. That morning, after the flash faded, Richard Carrington did the most scientist thing imaginable. He was worried nobody would believe him. Then the sky itself lit up over half the planet 17 hours later, and backed his little sketch with a global light show. One man, one card, one telescope, and 5 minutes of paying attention. The biggest storm in recorded history has an eyewitness, and he brought a drawing. I'm Mello. I dig up the wildest true stories out there, so follow along and I'll see you in the next one.